Good morning, maths fans. We're going to have a look through some of the questions today. We're going to have a look through question 10 through to the end of the problems today. I've chosen these. They're slightly more tricky than some of the earlier ones. Okay, our first question here is asking us to do something divided by 11 equals 17. In order to solve this, I'm going to have to do the inverse here. Okay, so I'm going to have to actually do 17 multiplied by 11. And I can use a quick formal method for that. I could of course do that mentally, which will probably be faster than doing it this way, which I'll show you in a sec. So I'm going to do 1 times 7, which is going to give me 7. I'm going to do 1 times 110, which is going to give me 110. And then I'm going to put in my place value holder, and then I'm going to have 1 times 7, which is 7, and then I'm going to have 1 times 110, which is 110. I'm going to add those up. I'm going to get 187. Okay, if I was doing that the mental way, to get the answer there, what I would do is I would go, okay, well 11 is just 10 times plus 1 times, okay, so 10 times that is going to be 170 plus 17, which is going to give me 187. Okie doke. Question 11 says 3 single-digit numbers multiplied together to make 504. Write the missing numbers. This one I'm going to need. I could sort of play around with this all day long and take me hours and hours, but I'm going to use a bit of knowledge here to help me out. So it's 3 single-digit numbers multiplied to make 104. They're going to need to be quite large because, for example, if I have something like 3 times 4 times 5, 3 times 4 is 12, 12 times 5 is going to give me 60, which is nowhere near my 504 that I need to get to. And because it's quite a large number, I know I'm going to have to use quite large numbers for this one. So I would probably be having a bit of a play around with this. Now if I had, for example, if I use 7, 8 and 9 as my numbers here, and I'm going to put them in and check that. 7 times 8 is going to give me 56. The way that you can remember that quickly is if you think about 5, 6, 7, 8, 56 is 7 times 8, 5, 6, 7, 8. So then I've got 56, and then my final digit would be 9. So let's look at what 56 multiplied by 9 would be. I can tell you there that I'm going to get quite close, because if I think 56 multiplied by 10, that's going to get me to 560, and so I know I'm in the right ballpark here. Okay, I could of course multiply by 10 and subtract 56, or I can use a formal method to work that through. Okay, so I'm going to do 9 times 6, which is going to give me 54 here, and then I'm going to do 9 times 5, which is going to give me 45 here. I'm going to add on the 5, that's going to give me a total of 50. I can bring that up because there's nothing else down there, which is going to give me my 504. So those 3 numbers there multiplied together to do that. The key in that one is spotting early on that you're going to need to use large numbers because the total is so high, and then also using kind of a range of estimation to have a go at that one. Okay, Dev has a bag of 50p coins and Holly has a bag of 20p coins. Both bags have the same amount of money, and that's key. Okay, here there are 30 coins in Dev's bag, okay, which means he's got 30 individual coins, okay, which means that he has those. There's 30 times 50p coins. Now I could work that out as do 30 times 50, okay, but I can also think, well, if it's a 50p coin, 2 of them are going to make £1, so that must mean that in Dev's bag he's got £15, okay, because 30 coins, 30 times 15p, 30 times 50p is going to give me £15, okay? So then I need to know how many 20p coins there are in Holly's bag. Now that means that in Holly's bag she has £15, okay? And I need to work out that, okay, if I think about this in a logical way, how many 20p's make £1? Well, 5 20p coins make £1. So I've got £15 worth of 20p coins, which means I have £15 times 5, because there's 5 20p coins in each pound, okay? So I need to do 5 multiplied by 15 to get my answer out here, which is going to give me an answer of, if I pop this into a method here, if I'm unsure of using this, 5 times 5 is going to give me 25, okay, and then I have 5 times 1 plus my 2 it's going to give me 75 coins. Okay, the other way that you can quickly and efficiently multiply by 5 is to multiply by 10 and divide by 2. Okay, because 5 is 10 divided by 2. So I could do 15 times 10 is 150 divided by 2 gets me to 75. Okay, there's lots of short and quick mental shortcuts that you can do with multiplication like these. Okay, question 13 is two two-digit numbers multiply to make 176. Write in the two missing numbers. Now, I would start off with this. This can be really daunting because you think of two-digit numbers. Two-digit numbers go from 10 all the way to 99. And if you were going to do this by trial and error, you could potentially be here all day trying to work this one through. Now, I don't like the prospect of that, and that seems like an awful waste of time. So let's think about this in a bit more of a logical way. If I start with 10, 10 is a nice easy number to multiply by. If I wanted to get close to 176 here, and I was starting with my 10, okay, or if I said, okay, well, what's 10 times 17? 10 times 17 is going to get me to 170. Okay, now that is 6 less than what I need to get to. So it can't be 10 times that. And we know that because I can't do 10 times anything and it not be a multiple of 10. So what would happen then if I did 11? Let's try 11 times something. Now if I did 11 times 17, it's going to be 17 more than 170. So it's going to be 187. So that's going to be too high. So that means that my 17 would need to change. So let's bring that down by 1. Let's go for 11 times 16. And let's see what we get then. Okay, well 11 times anything is 10 times it plus 1 times it. 10 times it is 160, plus 1 times it, which is 16, is actually going to give me 176. So that's a pretty straightforward way of pulling that apart, just by thinking first and foremost about that 10 timesness of it. That multiple of 10 is what we need to do for that. Okay, so that means that my two numbers that I'm going to use here are going to be 11 and 16. And because of the commutative law for multiplication, I can switch both my numbers around, and it doesn't matter which way. So if you put 16 here and 11 here, that's absolutely fine. Question number 14 on here is about a shop selling jars of honey and honey dippers. So what we've got here is we have our jar of honey and we've got a honey dipper, in case you were unsure of what they are. Chen is buying 3 jars of honey and a dipper. Lucky Chen. The total cost was £5.40 and the dipper cost 75p. How much did each jar of honey cost? So what I'm going to do for this is I'm going to draw these out and I'm going to see what that would look like. And when I mean drawing it out, I'm not going to sit here and draw my jars of honey like this, because frankly it's not very mathematical. But what I am going to do is I'm going to represent it using a bar model. So if I have this here, let's pop myself in a bar, and my total cost is the total size of the bar. Okay, so the total cost of everything here is what Chen paid, and that is £5.40. And the thing that you've just got to be really careful of here is that that is in pounds and that is in pence. So either everything's got to be in pounds or everything's got to be in pence. Now because 75p is less than a pound, I'm going to convert everything into pence to make that easier to deal with. So instead of £5.40, I'm going to go with 540p. Okay, so that's my total cost. That is my whole part of the bar. Now, the dipper that Chen buys costs 75p. So let's portion this bit off here. The dipper, D for dipper, costs 75p of our total cost. Okay. Now if the dipper costs 75p of our total cost, then we can work out what the rest of it is. Okay, now he bought 3 jars of honey. That's the other important bit of information here, 3 jars of honey. So if I then split what I have left into 3 jars of honey, that then will help me portion this out. So let's pop in one there. It's not going to be exactly precise, but it'll be about right. Okay, and then I'm just going to label them as H for honey. And hope Winnie the Pooh to come and steal them. So now I have that visual representation of what's going on here, I can start to really unpick what I have to do. Now what I'm going to have to do is I'm going to have to work out how much HHH is worth. Honey, honey, honey. I don't know that, and I want to know that. And then once I know that, I can divide that amount by 3 to work out how much 1 jar would have cost. But I can't do that yet because I don't know how much 3 jars cost. The way that I'm going to work out how much 3 jars cost is I'm going to do 540 subtract 75. Because I'm going to take my total cost of everything I have here, and I'm going to take off the cost of a dipper. And that's going to leave me with the cost of 3 jars of honey. So what I can do is I can just pop that into my method. I can do 540 subtract 75. I'll get my answer out there as 465p, or £4.65 for 3 jars of honey. Okay, now that means I can replace my green question mark down here with an actual amount for 3 jars of honey of 465 pence. Okay, or £4.65. What I then need to do is I need to say, okay, but that's not what my question asks. My question wants to know how much did each jar of honey cost? Each jar. Okay, so this is a big multi-step problem that we've got to work through here. So now I need to take my 465 and I'm going to divide that by 3 because I know that Chen buys 3 jars of honey. Okay, I'm going to use a short formal division method for that, or you can call it bus stop if you will. How many 3's go into 4? How many lots of 300 can I make from 400? Make 1 and I can carry 100 over into my 10s. How many groups of 3 can I make from 16? Well, I can make 5 there with 1 remaining. And then how many groups of 3 can I make from 15? 5 with no remainder. So it's 155p for each jar of honey. So I can either put 155p or I can put £1.55. Now, because it doesn't give you the unit of measure to do money within the answer box here, you can do whichever way round you like. Okay, I've put it back into pounds because it gives me the total cost at the beginning in pounds, but either way you're going to get the mark for that.